thanks. Well, good morning. Well, if you are watching this in the morning, but if you're watching it in the evening, then good evening or good night. Well, my name is Werner Florian, a future electronic engineer, and I want to introduce you to what is electronic engineering about. Well, before we get really into that, I would like to introduce you to some basic words. For example, a circuit. What is a circuit? I will explain you with this short demonstration. Okay, so now I want to introduce you to the resistor. The resistor is a special electronic device which applies an opposite force to the passage of electricity. I think it's clear enough like that. This force is called resistance, and it's calculated according to each resistor's color code. Now you will have an example of what's a resistor. Oh, sorry, wrong resistance. A resistor is mainly about applying resistance, as its name implies. Resistance is the opposition force to the passage of electrical current. And now I will show to you the transistor. To speak about something of transistors, they won't fight against electron tubes. Transistors utilities come from a wide range, so some of them they might be used as a rectifier, which is converting AC current to direct current, amplification, which is increasing the power of a signal, as a switch, which is something that interrupts and lets the current flow according to what you want, and signal processing, which mainly is about sensors capturing images, sound, etc. Now we can see a capacitor. Okay, now that you have seen the capacitor, I will explain you what this capacitor function is. The capacitor works as a battery. It has two layers. It's like a cylinder, as you saw, and two pins connected to two different plates, and they get charged with the current from the power source, and eventually they get to manage, in the case of a battery, the same voltage and current of a battery. They get charged, and a good example of how they work is when you connect your circuit from a battery to a capacitor to a bulb. You will see how the capacitor, as it charges, the bulb will stay lit, but when they end up already charged, the bulb will start dimming until it's off. Then you can unplug the battery and plug some wire, and your capacitor will be just like a small battery for a short and brief time. Going back to electronic engineering, now we can say that electronic engineering applies in the many fields of study. These concepts previously exposed, plus some that might be more complex to explain just as a word. Okay, let's go with the fields of study of electronic engineering. One of the many known is radio engineering. Radio engineer consists in the study of waves that electromagnetic waves which travel at speed of light, transferring information from a receiver to an emitter, sorry. Okay, we got telecommunication, which as the previous one, just that this time it focuses more on the transmission of information, not really how it is transmitted, but the effectiveness of it. Also, control systems, which are systems used to control other systems. It might sound quite simple, but as an example, I might say, like a manager in a store. The manager is the control of that system, the store. Okay, he sees everything, sells, money, everything that involves interaction in that system. Okay, also signal processing, as said, from transistors, it is about analysis of signals. Basically it is sensors. It's likely used in automatizations and robotics, but I will speak about later. And computer engineering, which is development of computer ICs, which stands for integrated circuits, which are circuits welded together in well, how to describe it? As you see, a motherboard is an integrated system. It has so many components welded together as one single element. Okay, so even in a computer we have plenty of circuits working together, having a microprocessor as a control system. That's I will speak about later. And solid state physics, a really interesting field of study, which it's a bit more theoretical. It's the study of solid and rigid matter through quantum mechanics, crystallography. Sorry, this one is a tough one. Crystallography, electromagnetism, and metallurgy. Okay, this processes quantum mechanics, electromagnetism, metallurgy, and the other one are just taken from other science to be applied with electronic engineers to perform the task the way it's meant to be performed. Okay, I would like to get back to one of the most important things that have changed the way we see everything today, thanks to electronics engineer, which started maybe some may said with the radio transmissions, the first radio transmission about 1960, before the First World War. I think it was 1930, something like that. Well, that was the beginning of the informatic era, which is the one we're living now, and the best time for electronic engineers. Okay, we started from the electron tube. It was something like this. Getting back to the electronic elements, components, I would like you to introduce my baby. It's a 2-amp regulator DC power supply. This one would transform from the electrical outlet, those 120 volts, into 3 volts, 4.5 volts, 6 volts. Very useful when working with protoboards. Protoboards are, maybe you have seen them, but not really you about them. They look like cookies. You see those crackers with a lot of holes, just that a proto board is a plastic board which has inside a copper sheet which acts as our conductive wire. So we test our circuits over it without welding it. That's the main use of it, and we use this baby to power it on.